Hello there, integrated science students, and welcome to our last video lesson here for Unit 2, everything about Earth's internal processes. For our fourth lesson, we are going to look at volcanoes. There's going to be four major topics that we talk about here regarding volcanoes, and they will be as follows. The first one, a definition and description of volcanic formation. The second one, we're going to talk about the products of a volcano and a volcanic explosion. Third topic is going to be a look into the style of explosion or eruption, okay, eruptive styles. And the fourth and final topic we're going to cover are how we classify them. So the topic of classification of the types or the groupings of volcanoes, okay? Let's get into our first topic. Deep within the interior of our planet, we've got the mantle. Now, many of you have been defining the mantle as being a layer that is composed of liquid hot magma. Yes and no, because as we move further and further and further in towards the center, the pressure gets so great that melting cannot actually occur. Okay, so some parts of the mantle, however, are hot enough to where melting has happened. All right, anytime that we have melted rock, regardless of the pressure of the situation, we have magma. So liquid molten rock, that's what magma is. If magma is then allowed to seep through some of the cracks of the actual solid mantle, super hot, rocky mantle, it can get to the crust and escape various areas of the crust. Magma, being hotter than the solid rock around it, is buoyant. So it will seep up naturally and look to escape. Okay? There are three exit methods, or three various spots that this magma is looking to escape from. Okay, the first one is a hot spot. Hot spots generally are a cause of a weakening area in one of the tectonic plates, and the magma can seep through those cracks or that weak area, eventually exposing itself, and the majority of the time creating nice little island chains out underneath some of those oceanic plates. Okay, Hawaii created through a hot spot. There's also hot spots that can exist underneath continental crust. Those are pretty nasty, all right, i.e. the supervolcano underneath Yellowstone. So hot spots, one of the three places that volcanoes can form, all right. The other two deal directly with plate boundaries. What do you know? We're looking at the plate tectonics theory once again here, okay? Just like we did with earthquakes. Divergent plate boundaries can offer a spot for liquid hot magma to escape the mantle and make its way to the above surfaces of our planet. So as those plates diverge from one another, the magma is exposed and it kind of leaks out, okay? Kind of leaks out onto the crust. And then finally, convergent plate boundaries, where we have subduction. With one of those plates going under the other plate, it's actually diving down, heating up, and it's melting. It can melt, seep back up through that plate that's going over top, boom, and erupt. And again, most part, land-dwelling volcanoes. The divergent plate boundaries would be underwater volcanoes. So those are the three areas at which volcanoes can form. And a volcano is essentially let me get the technical definition here. I'm going to read it from the text to make sure it's correct so we're all cool with what it is. Feature that forms when magma reaches Earth's surface and erupts as either lava or ash. Okay? So there's our definition. That's what a volcano is. Those are the three areas at which a volcano can form and kind of the three methods in which they can form. So products of a volcanic explosion. Three basic products: lava, pyroclast, and gas. Okay? Lava, we typically describe based upon its viscosity, its resistance to flow. We're going to look a lot more at this in our lab activity that we're going to do next class period regarding viscosity. So we're not going to get into that too much in the video here. We'll learn about that in class. But the way the lava flows, what is lava? It's that actual molten rock once it gets onto the surface. So it's magma as long as it's underneath the surface, and when it's exposed above the surface through a volcanic eruption, as one of the products, we call it lava, and lava flows. Okay? It can explode, and it can be blasted out from the volcano, but it also, for the most part, just flows. Okay? It's liquid hot rock, it flows, eventually cooling and creating new rock on the surface. Igneous rock to be exact. Look at that here in another unit. Pyroclasts are any solid materials that exit through the volcanic explosion. Those would be ash, cinders, okay, and blocks. Make sure you check those things out in your textbook. And we'll also look at those a little bit on our practice sheet here inside of the classroom. The last product of a volcanic explosion is gas. Tons of water vapor is released. The majority of the gas that's released from a volcanic explosion is water vapor, okay, H2O. All right. We've also got a substantial amount of carbon dioxide and sulfur dioxide. That stuff can be a little nasty, all right? But for the most part, it's water vapor. So the products of volcanic explosion: lava, pyroclast, and gas. There are three main ways that we describe the eruption style of a volcano. The first one is pretty mild, and that's typically due to the composition and temperature of the magma that's building up underneath that volcano. Anytime it's a mild eruption, it's because there's not a lot of gas that has been built up, trapped inside of that magma, and the pressure is pretty low. So when the eruption actually does happen, it's usually really, really runny, really, really hot, okay, and composed of materials in which we describe them as being mafic, okay? So if it's a runny, mild explosion, it's because the lava is really hot and it's mafic in composition. On the other side of the spectrum, we have a really, really thick lava. It's felsic. It's typically made up of continental crust. And it's really, really full of silicates. So it's really, really thick, and it does a great job of capturing gas. So it gets pressurized and pressurized and pressurized. And your really violent and large explosions from a volcano are caused by felsic, super viscous, very thick, not very hot in terms of volcanic explosion, lavas. Okay? That's what causes the nastiest, most violent. Alrighty? And then the third one, the intermediates. Somewhere in between being mafic and felsic, being super hot and somewhat cooled down. Okay? Being really, really runny and really, really thick. We've got our intermediate eruptions. Our last topic, the classification of volcanoes. Three major types of volcanoes, and we classify these volcanoes into those three categories based on their size, their shape, and their eruption style. The three types of volcanoes are as follows: cinder cone, shield, and composite. Cinder cone are typically the smallest volcanoes that we see, and they have a roughly erratic eruption cycle. All right, and they're typically pretty intermediate in terms of eruption style. Okay, those are cinder cone volcanoes, small in stature. All right, the actual shape of a cone, it's cinder cone, a conical shape as a volcano. Okay, and their eruption cycle is pretty irregular and or erratic, and the eruption style is intermediate. Shield volcanoes are the largest, both in terms of girth, so diameter, and height. Now, their eruption cycle, though, tends to be pretty long. These things can erupt for a very, very long time, long duration. Alrighty? But the eruption style is really, really mild. These are your mafic, super runny, really fast lava flows. Okay? Not very violent at all. Shield volcanoes get really, really tall and really, really broad because of the long eruption styles. It's just this constant, slow pouring out of lava running down the sides of the shield volcano, which almost ends up kind of just looking like a really, really long, double-sided wheelchair ramp. Composite volcanoes are the nasty ones. These are the ones that are typically really, really felsic in composition, build up a lot of pressure from the gases being trapped by that super viscous lava, and typically have the most violent of eruptions. They're kind of right in between shield volcanoes and cinder cone volcanoes in terms of size. All right? And they usually have an intermediate type of eruption cycle. Okay? You really can't predict when these things may go off until it gets really, really close and really, really obvious. But composite volcanoes, okay, usually don't have as long of an eruption style as a shield volcano, so it doesn't take nearly as much time. It doesn't last as long in terms of the lava flows, okay, but it's still more than that of its cinder cone. So it's kind of right in between those two in terms of duration of the explosion. But the actual style of eruption, very violent, very nasty. And the actual size, kind of right in between cinder cone and shield. There's a fantastic table on page 795 of your textbook that breaks down each one of these volcano types based upon the gas content, its viscosity, the silica content, okay, so the actual rock and lava material, and the composition of that rock and lava material. Okay? That does it for this video. Hopefully you feel pretty comfortable now about the 4 major topics for this video. A general definition of what a volcano is, where they form. Okay. Also, you need to be pretty comfortable with the products of a volcano, the styles of eruptions, and last but not least, the types, the ways that we classify these. Hit me up with any questions. Be ready to apply this stuff in class next time. See you guys later.